Namaste. In this segment, we would be looking into the concepts of capillarity. A prerequisite to the theories and things of capillarity is surface tension. Capillarity is a phenomenon where liquid rises into a thin glass tube above or below its general level. Now, based on the rise or fall, we classify the capillarity as capillary rise and also the capillary fall. Capillary rise will happen in the case of wetting liquids, whereas in case of a non-wetting liquids such as mercury, capillary fall will happen. If capillary rise is expressed in terms of H, positive H, capillary fall is expressed in terms of minus H or with a negative sign. We'll just try to understand how to calculate the expression for capillary rise. Let's say we have a trough where water is filled and there is a capillary tube here. The diameter is almost like 8 to 10 mm. The diameter of this tube is d, and there exists a rise in the general water level comparatively into this capillary tube. If d is the diameter of the capillary tube, sigma is surface tension force per unit length, and W is weight of liquid, theta is angle of contact of water surface, and gamma being the weight density. Then the exaggerated view of this section is this. The surface tension force will act all along the boundary of this liquid, and if theta is the contact angle, angle of contact, sigma can be resolved in vertical direction as sigma cos theta. There are primarily two forces. One is a force which is calculated from the surface tension, and the other force or the weight is weight of this liquid which is standing for a height of h here. So here the upward surface tension force is equals to weight of water column in the tube for a compatibility condition. The upward surface tension force is nothing but circumference into surface tension, and the weight of water is volume into weight density. So circumference into surface tension is pi into d is circumference into surface tension in vertical direction is sigma cos theta, and that should be equals to the volume into gamma. Okay, now more simplification related to the right hand side. The volume is area into h. H is the capillary rise. So pi d sigma cos theta is pi by 4 d square. H into gamma. You can simplify for h here. H is nothing but 4 sigma cos theta by gamma into d. Now here is a picture where you can very clearly see that wherever the value of d reduces, h increases. A very thin diameter capillary tube will have high rise in its capillarity, whereas it decreases with the diameter, increase in the diameter. Some points to ponder at this moment. There is a minimum diameter which is fixed for the glass vase, which I use to measure the rise of liquids in laboratory, and it is fixed as around 8 mm. The capillary effects are neglected for the tubes larger than 12 mm. So there is no capillary effect for the tubes which are having diameters more than 12 mm. So for pure water, theta is considered to be 0 degrees, and it is almost 25 degrees for contaminated water. There are two types of surfaces or liquids. One is wetting and the other one is non-wetting. In case of wetting liquids, the example is water. Theta will be less than 90 degrees. And for non-wetting liquids, theta will be more than 90 degrees. Example is mercury. So in case of mercury, liquid fall is happening, H with the negative sign. In case of water, you observe capillary rise.